Hello, everybody. This is the second seminar of winter term. And so what we're talking about in here today is selecting medical hardware using a systematic decision-making process of pairwise comparisons. And this is a patient's perspective of cochlear implant device selection. So a few of you may have heard versions of this talk before. There's updates to this, and so this is a line of work that I'm closely familiar with. And so the idea here is this is a work that started in 2016. It's been revised in 2022 and further updated just this week. And so there's a chat message, particular limit of words. As long as it is under 1 or 2 pages for under 2 pages for the report, that's okay. If it is longer than 2 pages, there may be point deductions for that because it's not necessary to get that long. The idea is not to necessarily write really long essays in here. And 1 page should be fine as well in general. Okay. So in here, the speaker today is myself, Tim Anderson. Shabnam Arjaromi was a PhD student in the ETM program years ago, and she contributed to some of the early versions of this work. So first of all, an update on this topic of cochlear implants. Cochlear implants are for people that have profound hearing loss of a sensorineural nature. And so over 1 million have been implanted worldwide. This means people that have hearing issues that are from a less formal explanation, hearing issues that are past the eardrum. If they simply have an eardrum issue, an outer ear area, there's not as much, there's not a need for a cochlear implant. There's other technologies that work well. If they have mild or moderate hearing loss, oftentimes hearing aids will work quite well. But if they have profound hearing loss and the hearing loss occurs essentially deep down in here in areas such as what's referred to as the cochlea. The cochlea in blue in here is an organ inside everyone's inner ear that is the size of a green pea. It's the a very small size, and it's essentially a looping shape in here that is suggestive in this picture. And so that is where in that fluid-celled organism, everybody has hair cells that wiggle, that trigger their hearing to the auditory nerve. The hearing nerve, drawn in yellow in here, then carries the signals to the brain to decode, to provide sound. And so that's the way an ear normally works. That the eardrum essentially conveys to bones that are then vibrated, that then vibrate the fluid in the cochlea, as well as then vibrations carried through from the skull also essentially cause vibrations into the fluid in the cochlea that are then decoded as sound. A cochlear implant, it essentially is bypassing the majority of those physical structures that exist in the human ear. And what it does is it has an internal implant. It has in here an internal implant that has a magnet and a processor in there that gets a signal and has an electrode then that gets run through a hole in the skull into the cochlea then, and essentially loops around inside of the cochlea, following the structures in there, and has 12 or more electrodes that fire to then trigger the auditory nerve, in place of relying on the hair cells that wiggle with the vibrations in the fluid. And so essentially this is a system that is electrically replacing a mechanical system that has had a breakdown for one reason or another. Over 1 million of these surgeries have been done around the world now, since the technology first started being done in the 1970s. And so it's been developing. In the US, there are 3 FDA approved companies that are providing the implants. These are essentially the 3 possible choices: Advanced Bionics, Cochlear, and MED-EL. 3 companies that essentially have 100% of the market in the US. There were earlier companies in the 1980s. They've gotten out of the business now, and so, but only 3 continuing in the US, and they all use essentially similar overall technology. So in here, the problem, the decision. I mean, patients are asked to select a cochlear implant device. I mean, seems easy. Pick. There's 3 different companies. I mean, we've all made major decisions before. Every one of you watching this right now have made a decision, for the most part. I mean, what you're going to study in college, major decision. Where you go to college, and what classes you sign up for. And we're making a similar decision here. In fact, you've made decisions, similar decisions, what kind of cell phone you're going to use. Am I going to use an Android, an iPhone, a Palm OS? But kind of one aspect of this is vendor lock-in at its most extreme, because whatever internal device that you choose will dictate the external ones. The outside part, there's an external processor that would sit outside, that was shown in that previous diagram. In here, there's an external processor sitting out here, or shown up here, this disc, and then the part that sits on top of the ear, that external sound processor. You can upgrade that every 5 years. And they'll come out with new versions every 2, 3, 4 years. You can upgrade those, no big deal. But they are not interchangeable between companies. Whatever company you pick for the internal, you're going to stick with that on the external side for the rest of your life. And so this would be equivalent to making a decision which kind of smartphone you're going to want to use, not just for today when you go and buy a new cell phone, but you never get to change that choice again. Go with Apple, great, you're sticking with Apple for the rest of your life. Go with Android, you're sticking with Android for the rest of your life. You're never going to change it, because it would mean pulling out, removing the part that is internally implanted. And the idea that that's an electrode about 2 or 3 inches long, that is running inside through your skull into the cochlea, into this sensitive internal part. You don't want to change. If you think it's hard switching from an Android to an Apple phone, or an Apple phone to an Android, it's nothing compared to changing out the electrode in there. And so, adapting to the new technology, a new device in here, takes a lot of time and effort, and it requires surgery. So you want to make that decision very carefully. Android, versus Apple, they have their trade-offs, and it's a similar decision in here. But just think, 6, 7, 8 years ago, if you were making that decision, you might have a decision, am I going to pick for a Palm OS phone, for example, maybe a little further back. But the idea of a BlackBerry or a Palm OS phone as one of those earlier companies in the industry. And if you had that selected, you would be stuck years later with no upgrades available to you, because the company is essentially not upgrading and providing new phones using that technology. Same idea here. You want to avoid picking a company that's essentially going to be out of the business 5 years, 10 years, 20 years down the road. Another part of the aspect that is very different from picking a cell phone is, you can go to the Apple store and try out the new phones. You can go to the AT&T store and try out Apple phones right alongside the Android phones, for example. You can't do that when it comes to a cochlear implant. There is no accurate way of simulating what hearing is like on each of these 3 different company phones. There's some efforts to try to create simulators, but they're not well accepted as representing what it's actually like. This is a very complicated research field where they're doing biomedical engineering, trying to figure out how to best provide this. So, and engineers, it's a challenge to figure out, how do we even represent what it's like hearing using these technology devices? So there's no way you can try it. In fact, to try it, you actually have to undergo the procedure requiring surgery to medically implant this device. And once you get implanted with one, you can have surgery again to implant another, but you really don't want to do that. And people have done it, but only when there's a problem with the original device, or their original company's gone out of business or is no longer in the business. So essentially, the idea is, once you implant it, the goal is to never have to change the internal part that is underneath the skin and running through the bone into the cochlea. And so think about it from a decision-making process. When you or I go into an AT&T store, we're familiar. We're all cell phone users. We've been using cell phones for years. We have friends that have used these that can tell us what they recommend, why they like an Apple better than an Android, or an Android better than an Apple, a Samsung versus a Pixel. People all can have their opinions. We've seen them advertised. You can look online and see reviews on these, where maybe people do comparison side-by-side reviews, all kinds of rich information for the decision-making process. And we all have understandings of what might be important for you in each of these kinds of usage cases. How important is it to be able to use FaceTime to talk to your friends, for example, and your family are all FaceTime users on Apple, versus maybe users that use Android because they want the to be able to have easier programming and customization capabilities. Each person has differing characteristics and pick the tool that works best for them. In the case of a cochlear implant, the decision-making process is again more complicated. Parents might be asking to need to make a decision on behalf of their child, a child who might be as young as 1 year old. They're doing cochlear implant procedures on kids now as young as 1 year old, so that they don't miss out on hearing in the earliest stages of life. And so as they're trying to develop hearing skills going on into the future. So parents now are being asked, make a decision, choose which of these three companies, A for Advanced Bionics, B, Med-El or Cochlear, and then the third company, pick one. But you don't get to use it. Only your child's really going to be using it. You're making a decision that is hopefully for the rest of their life and hopefully not needing to make changes. And you, as perhaps in all probability a normal hearing parent, don't have a real perspective on what it would be like to use any of the devices, because you can't use it like you would in a store to try out different devices.
If you don't mind, can I ask a question?
Sure.
Okay, so when the parents are making the decisions for the children at their early age, as the children's body are growing, so the implant doesn't cause any issues?
It actually surprisingly does not cause any problems. The human cochlea is stops growing and does not change in size after 6 months or so, or a year of age. And so that's an excellent question. Surprisingly,
I didn't know that.
it works. And part of it is because of the way sound is conveyed in there, it needs to be of the right shape and length and not change, because sound is transmitted through the cochlea, and for them to hear the full human range, it needs to be the right shape and length as a newborn child. So excellent question. But again, if you can put yourself in the position of someone with an infant child, 1 year old, that is deaf, and now suddenly among all the other challenges as a parent of a newborn, hard enough. As a parent, hard enough when your child is 12 years old, suddenly to be confronted with the fact that your child has a disability that is permanent and lifelong, and all the challenges that too entails. And now you're having to make a decision, A, B, or C. Pick one, and you're making a decision that will have impacts for your child for the rest of their life. And so tremendous responsibility. And that decision of 3 different companies is challenging, because the companies, most of us are electrical engineers that are here. Think of this. I'm going to show some technical specs on how these 3 different company products differ in complex ways. And you can tell me which one you think is the most sophisticated technically as an electrical engineer, for those of you that are double E's. So so again, another aspect, whole different category of users, elderly patients. And so think of maybe your parents or grandparents having to make a similar decision in their 70s. Many of the implantees are in their 70s as well, making a decision. Now, they may not be concerned about using something for 60 or 70 years the way that we would be deciding for a newborn child right now, but they want something that's easy to use, friendlier. It just has to work potentially, because they may not be as tech savvy as that 1 year old will become by the time they're in their 20s or 30s, the age of most of you that are on the seminar here today. And so think about how every person's criteria and factors in these decisions will be different. What's important for one group of users will be very different from what's most important for another group of users. And so no single solution might be perfect for everyone. So how do you make these decisions? And by the way, the doctors, you could just say, doctor, you choose. But it turns out in a lot of the clinics, they don't want the doctors making the choice. I mean, if there's a medical reason, if there's a reason that they say, I mean, one company fits your ear better or is medically better for you because you've got a malformed cochlea, you've got essentially something that is not shaped right or some medical reason, great. Then make that specific medical choice. But it turns out that there's a profit possibility in here, and they're worried. They seem to be worried that doctors could be influencing people to choose things in a way that could be inappropriate. And so, I mean, the doctors have conferences in Hawaii or other places where each of these companies would be glad to send the doctors, all expenses paid, as long as they can do this. Because what do you think the cost of these devices are? I mean, for a surgery, I mean, what do you think they bill to insurance for this in the US? Feel free to throw a few guesses into the chat. What you think the cost of a device in here is, including the surgery cost. I'll give a moment for people to try throwing it into a chat. So try guessing what you think the cost is. And now bear in mind, oh, okay, the first response in here was Atia saying $50,000 to $80,000. And Atia, well done, congratulations. Oh, Lazia said $1 million. That's a little high. The cost in the US is approximately $90,000 for what they will bill to insurance for the procedure and the hardware. And it doesn't cover all the ongoing costs of follow-ups and everything else, but about $90,000 is what it is right now. And if you decide to go to, say, Thailand and do a medical tourism, have the procedure done there, you can probably do it for about $50,000 is what I was seeing quoted. So I mean, the device, the process, there's high profit margins in here where the companies, it would be well incentivized to try to steer doctors to help pick their devices over another. So instead, what clinics generally do is they send the patient home with a stack of 3 different brochures and say, great, here's your 3 choices, come back next week and we'll fill out the paperwork for which one it is. And so you've got a week to make a permanent life decision. Do I pick one company or the other and another? And the technical details require great fluency in digital signal processing. I mean, people here, if those that are electrical engineers might say, oh yeah, I remember digital signal processing, but it also requires things about biophysics and audiology and more to really appreciate. And even then, it's not necessarily obvious what the deepest technical differences are between each of them. And so in here, again, here's just the components that we can think of it as the physical components. There's a microphone speech processor in component A that provides the signal. It's a microphone that, or a set of microphones, and a processor that tries to get the signal to then pass it along to the internal side. There's a magnet portion then that adheres through the skin to the internal part and uses a magnetic connection to both transfer power inside the body, so you don't have to have a battery, for example, internally. It transfers the power inductively across the skin, as well as the signal of what to do, what the sound is through that inductive signal through the skin. There's a magnet then, part C, internal underneath the skin, an internal decoder, a processor that will then take the signal and figure out how to convey it onto an electrode and fire the electrode pulses in a way for the human ear, human hearing nerve to decode as a signal. And there's a website, cochlearimplanthealth.com, that talks about this and a lot more as well, and has a lot of data for people that are interested in this domain of biomedical engineering. Here are alternatives. These are the ones that are available as of 2022, 2023. And so Advanced Bionics offers, essentially, they're the same device. It's called the Marvel CI-M90 or the Sky M90. And one is considered for adults, one for pediatric, but they're essentially the same thing. Cochlear and MED-EL offer two distinctly different kinds of devices. In the case of Cochlear and MED-EL, they offer what's called a behind the ear that would sit on your ear. And then the Ronda, or they offer a secondary unit that is what's called an off the ear unit, that essentially the top ones have both a processor and magnet that sits on the ear, and then a little magnetic disc that you can see that is attached with a short little cord and sits on the top of the magnet. Both Cochlear and MED-EL offer an integrated unit that combines both functions into one unit that just sits on top of the magnet away from the ear. In these COVID times, when so many of us are wearing face masks, for example, I mean, it's nice not having something hanging onto your ear. Having something that can sit up off of it could be a great convenience. In fact, for many clinics will offer not one, but two processors. Even if you do just one ear, they'll offer both devices. And so you have a choice of two units. You could get two of the same to have a backup in case one fails, or you can get one of each to try it out and see what you like. So again, different trade-offs in here for people. The technology for each product, the convenience of a single unit versus the separated units. And so in here, that can feed into the decision-making process. Here are the three companies, and the internal part doesn't change depending on whether you use a behind the ear or an off the ear model. The internal part is the same, but it's different for each of the three companies. Advanced Bionics, their internal part, and this describes the channels and the electrodes for the wire that is running in there and the signaling mechanism. And so that easiest, all of these are a little tricky, but in here, the number of electrodes are spots where distinct electrical signals can be transmitted. Advanced Bionics has 16 electrodes. Cochlear has 22. MED-EL has up to 24, but that's because they're counting kind of a positive and a negative, and it kind of is more like 12. But there's a reason for which it can be double counted. But their electrode drivers, Advanced Bionics and MED-EL can potentially drive each one separately, and Cochlear is essentially just firing. It has one driver, and will, even if they have 22 different electrodes, they'll fire them in rapid succession. But only one firing at a time, whereas MED-EL or Advanced Bionics can trigger all 12 or 16 simultaneously. And then the RF carrier and data rate, this is, again, I know we've got most of the people here are engineers. Many are electrical engineers or IT people. I mean, in here, the RF carrier and data rate is describing the transmission across the skin. And this is a data protocol designed and built in to the hardware internally that can never be changed. And so one question is, which one do you want? In here, the RF carrier, radio frequency carrier frequency varies 49 megahertz, 5 megahertz, 12 megahertz, different values in there. But also, perhaps more importantly, the data rate tells you a maximum amount of data that you can be transmitting across this barrier. The Advanced Bionics designs it with a 1 megabit per second, Cochlear at 0.5, and MED-EL is 0.6. So this is essentially telling you the maximum data speed. It would be kind of like, again, whatever you get, you're stuck with forever on the internal side. If you think of it from cell phones, that would be kind of like being stuck with potentially a 2G phone for your capabilities forever if you have bad technology on the internal side. And so you want something that provides data headroom for the future. And so in here, none of us are really using 8086 microprocessors like some of the original PCs, or 8088s, like the original PCs from the early 1980s. And so we're all using ARM architectures, for example, for our cell phones in one way or another. Pretty much everybody's using a modern 64-bit ARM architecture CPU for your cell phones. And it's kind of like here, you could be potentially tied to a data protocol that's defined from 20 years ago. So you want that to be good. So in here, which one is best for an electrode? If we had more time, I'd throw a quick poll up there and ask people, but it's not necessarily obvious. And in general, the experts that I've talked to generally say Advanced Bionics has a pretty sophisticated technology, as demonstrated for one reason by their higher data rate of 1 megabit per second. The MED-EL has also what's considered a pretty sophisticated technology, but slightly higher data rate than Cochlear, but also because they have a longer electrode that's able to be inserted deeper. That's not shown in here, but essentially they have differing trade-offs. Advanced Bionics has had some more issues of reliability, recalls. Product recall is a really bad thing in here, because if you have a product recall or failure, it means having surgery to remove the internal device and insert a new one in. And that's really not something that you want to do. And so, in here, the decision maker that was worked with in here had a number of different criteria that were factors for them. And so in here, the criteria: performance. What's the current implant technology? How good is it at being used right now? The main external unit, how good is that if the patient is in a 2-processor clinic, how good is that one that is likely to be the primary option? And how good is that unit's waterproofness? Because in fact, especially when the first decision was made back in 2016 by the decision maker, these varied quite a bit in terms of how waterproof. If you were living in Oregon, we've got a lot of watery, wet days, rainy days, and you don't want to have to go around walking around all the time, covering your ear, your device to keep it from getting wet, or take it off of your head to keep it safe, and then be walking around deaf without hearing capabilities. So how good is it there with waterproofness and dustproofness? How good is the secondary unit for example, that device that I was showing that sits off the ear? How good are the bonuses that you might get, such as a free upgrade? Future issues. What's the future likelihood of improved performance over time? Do you have a protocol designed that is your implant going to continue to be able to have more opportunity for improvement over time? Or is it so limited? Think if you were limited for your technology to USB 1.0 for your devices that you were using right now, as compared to using USB-C and Thunderbolt and USB, the latest generations with high data, high power delivery and otherwise. So you don't want to be limited by something as much going into the future. Warranty and reliability. I mean, which company can you trust most, given that you're going to be relying on this long term? So all of these are factors that could be valued and valued differently for different types of users. So let's demonstrate more about what that would look like. Based on the 2016 analysis, a pairwise comparison approach was used. We'll show a little bit about this. In the interest of time, we'll keep this moving. And so here, for example, is a pairwise comparison set of weights assigned to these criteria. And so in here, this is saying comparing each criteria against each of the other criteria, which one's most important. This is saying current implant, the part that goes underneath the technology capability, for how high a resolution, how high a fidelity it will provide, for example, versus the niceness, the convenience of the secondary unit. And so the idea is, this is saying a score of 60 for that the implant technology is more important by about 1.5 times as important. If you gave 60 points to current implant technology, 40 to that secondary device. And so each of these, the decision maker walked through putting his or her weighting on each of these criteria to say what was more important. The item on the left was more important if it got a score higher than 50. And a score of, say, 75 means this is much more important. The quality and the performance of that main unit is much more important than the secondary unit as demonstrated by the 75. So the decision maker walked through doing a careful, what's most important to them analysis in here. And it would be different for a person who is in there, deciding for their child or deciding as an elderly person. The user in this case was in their 40s or 50s. And then once that was done, they compared each of the three companies on how well they did with respect to each of these criteria. And so in this case, it said the current implant technology was better for Advanced Bionics compared to Med-El. They said the technology is better there for Advanced Bionics, and even more of a difference for Advanced Bionics over Cochlear, and that Med-El was better than Cochlear. So they said based on what goes underneath the skin and is never changing, the winner seems to be Advanced Bionics. But on each of the other criteria, it seems similar. For example, the decision makers said they all seem pretty comparable in terms of warranty, reliability, et cetera. But the future implant technology could continue to get better with Advanced Bionics with that higher data rate. So, and then with that, it comes out with on each of these values, which company was best. I mean, the preferred device on each. And we'll show that again, revisiting. Oh, and so in here, this was the 2016, came out with a drum roll. Oh, a drum roll of the winner essentially being, in this case, Advanced Bionics with a overall score of 0.39, Med-El coming in second place with a 0.34 and a 0.27 for Cochlear. So in this case, the decision maker said, I'm going to make that decision based on a systematic analysis, objective analysis, trying to wade through all the marketing material, buzz and pressure to pick Advanced Bionics in there. And so the decision maker made that choice. Now that was 2016. The decision maker, it turned out, they were rejected for 2016 by insurance. Insurance said, sorry, no dice, you don't get to do this. And so they had to wait. And so that what they did is they came back, and in 2022, insurance approved the procedure. And so then they had to say, I need to make this decision all over again. Every company changed their hardware, the implants, the external parts. And so the decision maker said, it'd be crazy to not revisit, to not go back and look at the analysis and update everything. So the decision maker, 6 years later, went ahead, re-examined everything, said, I'm going to look at it again and redraw the issues that matter for now. For example, waterproofness doesn't really matter as much. They've all gotten good on waterproofness. But the decision maker learned maybe there's other things that matter, like the clinic, how good and familiar they are with it in the clinic that they're using. And so you want the doctor to feel comfortable with the surgery because their skill on inserting that electrode, the electrode is a soft wire that you're inserting and pushing into a fragile human organ. And so people have sometimes made an analogy that inserting that electrode, it's about 2 or 3 inches long, is kind of like pushing a garden hose. And so pulling a garden hose is easy. Pushing a garden hose where you want it to go is really hard. So you want a surgeon that's good at doing that very carefully and has a lot of experience. You want the audiologists that you'll be working with for years later to be comfortable with this as well. So the community of people that you can work with, because you're going to want help from other people in doing this. So connectivity, Bluetooth and Wi-Fi connectivity. And so the MED-EL community, a network effect. Yes, it's there is a community there. And all 3 companies have their own communities that serve as support, user support communities, user groups, essentially. Flexibility for usage, the implant. So again, all 3 companies were graded in here. The importance of each criteria also factored in. For this user, implant was still the most important criteria with a 30% score, and connectivity and community were important, but about half as important. And so running through the numbers in here, in this analysis, Advanced Bionics came in number 2 this time, followed closely by Cochlear, but in this case, MED-EL was the winner. So in here, the person made that decision in 2022. Limitations, this is a pilot study, a proof of concept. Based on one patient's perspective, everyone will have different importance for criteria. What matters for one will be different from what matters for another. And the patient's not representative of maybe a typical cochlear implant patient or decision maker. People can have different forms of deafness, different sources. And so in this case, the decision maker suffers from what's called single-sided deafness, where one ear works perfectly fine, one ear is deaf. Experience. Oh, it turns out the decision analysis, the decision maker in this case is an experienced decision analyst and technically capable. In fact, in this case, the decision maker, the patient, has electrical and industrial engineering degrees. And so the patient that I'm speaking of in here, 1 or 2 of you may already either know or guess, but any idea who the patient is, that for those of you other than Chip that have Not heard this talk before. Feel free to throw it into the chat. Any idea who the patient is?
Are the patients are engineers?
The patient, the decision maker in this case, I see Chip smirking in here. He turned on his video. The patient is an electrical engineer. The patient is somebody familiar with the decision analytics. In fact, the patient is the very person who is speaking right now. I'm the patient and the decision maker, and this is a Med-El cochlear implant. And so the drum roll of this is I started getting deaf 15 years ago when I picked up the phone in my office. And normally I would pick it up and hold it up to my right ear and talk to someone. But I had the office stuff rearranged. I moved the phone to my left side, and I picked it up and held it up to my left ear. And I said, who is this that's talking to me on the phone? I had no idea who was calling me. My phone didn't have caller ID. It sounded like a robot, an alien speaking with 1980s technology voice synthesis. I could understand the words, but I'd never heard that person talking to me before. It sounded like a crude 1980s computer talking. Moved it over to my right ear. I recognized it. It was my wife talking to me. Left, alien, robot, bad computer program. Right, my wife. And so with that, my hearing was going downhill. Year after year, it kept getting worse. They ruled out any possible fixes to it and said, sorry, tough luck. Somewhere down the road, you're going to need a hearing device, whether a hearing aid or otherwise. And 7 years ago, they said the right decision would be a cochlear implant. Insurance company said, no way, we're not paying for it. FDA does not say it's medically necessary or proven to work for people with single-sided deafness. And if we can avoid paying $90,000, we're going to do it. So sorry, reject, reject, reject. Every appeal by the doctor, rejected. I went in, made a personal presentation similar to this, walked in, made a presentation to their doctors and the people in charge of the final appeal. They came out and said, excellent presentation, Dr. Anderson. This is the best presentation we've ever seen from a patient presenting on the benefits of a medical procedure to try to get it approved. 2 weeks later, I got the letter in the mail, rejected. We're not paying for it. And so 2 years ago, they ended up, the FDA said, the research proves that this is a good medical treatment, even for people with single-sided deafness. And now insurance says, shucks, I guess now we have to approve it. So now they approved it. I had the surgery done 3 weeks ago. I had the device activated 2 weeks ago, and 1 week ago, and I've been using it now about 16 hours a day ever since. So I'm using it and essentially living this. A week ago, last Friday, I was meeting with a mechanical engineering student who was kind of doing mechanical electrical systems. And I asked him, so what area are you most interested in? He said, I love embedded systems. He said, do you know anything about embedded systems? And I said, funny that you should mention that. You might be studying embedded systems. I am living embedded systems. And so you can't get any more embedded than a cochlear implant. And so in here, I've been living with this now for over a week. And it's interesting, it's different. I'm going to give a little more as we provide this. The decision-making process and weights have changed, the technologies change, but I still think it's providing a better way of balancing the complex trade-offs when you're making what is truly, a lifetime decision. And so I could look at other criteria, implant size, battery usage, ease of use. There's hard to have all the possible criteria, but effectively try to wrap some of these in. And so again, Initial decision history, 2015. I originally chose Med-El, and
Yeah.
then after looking at it more carefully, changed my decision based on this pairwise comparison to Advanced Bionics using the analysis I showed. Technologies change, the products from each of the companies have continued evolving. And back then, it was probably because of overvaluing the importance of that second device, the external unit. When I look at it in 2022, I reevaluated things. I don't even count secondary unit as a separate criteria, but I roll that into the flexibility, the usage of it. And now when I look at the criteria, it turns out Med-El wins again in this case. And that's what I went with. I actually talked with an Arizona State adjunct professor who had a cochlear implant device on one ear. And what he did is he breadboarded, he reverse engineered the whole proprietary system. He reverse engineered his own separate processor unit. And he can't miniaturize it as well as the company, but he created a standalone external processor with microphones and everything else, and used that to go to a symphony. And he could adjust all the settings himself, and demonstrated, worked with the research teams in a lab there at Arizona State. And then years later, ended up getting a cochlear implant on the other side. I can't imagine the amount of work to try to reverse engineer the protocols, building, coding your own system, and making it safe enough, because you don't want a transient electrical current to go in that is too strong, that could damage things internally. But he had on the other side another cochlear implant inserted, but because he is the ultimate hardware hacker, he ended up actually not inserting the same company's electric. He switched on the first side, he had Advanced Bionics. On the second side, he went Med-El. And so he's now using both of them as well, and has two separate breadboarded reverse engineered systems on both sides. He's the only person I know of in the world that has done this. And that's a level of hardware hacking that is way beyond what I would ever dare doing or have the time to try to do, but fascinating to talk to. This is showing in here the final decision 3 weeks ago. I went with surgery on the very first week of school. That's part of why we didn't have a seminar in week 1, is I was recovering from surgery. I had a great big bandage wrapped around my head and a big thing stuck on the side of my head that day. And I was on painkillers that week. So we had no class that first week because I was having holes literally drilled into my head. If you thought you had a rough first week of class, I don't recommend having holes drilled in your head during the first week of the quarter. And so then last week, on the 26th, I got the processor. I got the devices. This is one of the two. And now in last week, they cranked up the adjustment. It turns out it is adjusting over time, but it's as much about the brain rehabbing as it is the processor. And so the brain is having to readapt to not getting useful signals over there. For 15 years, the brain was saying there's not much signal there. Let's just start ignoring what's coming from the left side. And so now it's day by day trying to adjust and listen more and adapt to it. So there was a question asked, 2 different wavelengths. It's mid-wavelength is 2 different mechanisms, but they're both firing on the good ear. They're firing the electrical. The hair cells are triggering electrical impulses on the auditory nerve that are then going into the brain. The same thing's happening over here, but it's not it's not the same resolution. The human ear has tens of thousands of hair cells and a fine granularity of picking up different frequencies. And so with the electrode, in theory, there's a lot of electrical tricks being played to try and provide intermediate tones, but in some ways it's like you've got 12 or 16 electrodes firing different signals. And so that is, from one perspective, the maximum number of frequencies that you can get on this electrical side. And so there's different ways of trying to adjust that, but thousands of frequencies that can along the continuum of what's available on that versus 12 discrete or 16 electrodes and frequencies. So it's different. And the brain is an amazing organ. The plasticity of the brain, many users will then fuse the two and recognize them as being equivalent. The brain does a great adapting to it. A failed implant rate during the surgery is a question. It's seemingly less than 1%. It does happen, and what they can do is they can take that out and reinsert. You don't want to do it, but it can be done. There is also a device failure rate of about 1% in for devices after they're implanted. The human body is not the most conducive and friendly of environments for devices. And so you can have reactions in there, as well as any piece of electronics can have a failure that happens. A microprocessor that gets manufactured, you can have a premature failure. And in here, you're using a very sophisticated system, no matter how. You don't want one of those wires having a short in there in the electrode. If so, you could be missing out on signals and potentially have a failed device. So, so in here, a device failure rate of about 1%, and I'll give the comments. In my case, they said you had a perfectly smooth surgery, perfectly smooth. All electrodes are firing and working correctly, and now it's a matter of adjusting. And so every day it's an interesting process in adjustment. And there's a lot of really cool technologies that are being developed beyond this as well. For people that don't even have a working neuron, a nerve that goes in there, there's direct brain auditory brain implant activation, where you can set an electrode system for stimulating the brain directly in that right region and try to teach the brain. It is lower resolution than this system, but is possible to bypass the ear activity completely. That's one wild technology that is being used and approved. Another one is inserting gene therapy treatment to try to regrow hair cells that have been dead for years in there. The human cochlear nerve cell, hearing cells do not regrow. When you go to a loud concert, if you have loud noises that potentially cause hearing loss, it can kill those hair cells, and they don't regrow in the human ear. And then in mice, they can, lucky mice, but they don't regrow in human beings. And so if you kill off your hair cells by exposing it to potentially a virus or other things early on, loud noises that potentially overdo it and cause problems there, those never regrow. And that's part of why you see age-related hearing loss and people in their 70s that need to have hearing aids of increasing power over time. And so they're working on gene therapies where you could inject a chemical or a virus that will then pass along genes that cause those hair cells to regenerate and grow. Don't bank on that treatment being available to people in a year or 2 or 5 or 10. And I know that they're working on it. They have clinical trials, but I decided to not wait further and to get the surgery now. And so amazing what's happening in there with all kinds of things. They're also looking at, instead of electrical impulses, using light impulses to trigger the neurons in there. And so there are, again, trials being done, animal trials that have been done using that to prove its efficacy. In 5 or 10 years from now, they may use light emitting systems instead of electrical pulse systems on those internal implants. Great for the people 5, 10 years from now. I mean, I won't be able to switch that out myself. I'm committed to the electrical side, and now what I have 5 years from now, I'll be able to get an upgraded version of this external processor. But what I have internal, I hope to never change for the rest of my life. And I hope I'm a user of it for a good long number of years. And so, again, these were the results, the weights, the analysis that I did in December 2022, when I had to make that decision between the 3 companies. And then what I did is I made my decision, got surgery in January, and now I'm, for better or for worse, I'm living with the impact of my decision from back in December. And I feel a little better about it because I used a systematic approach rather than just trying to look at the piles of marketing materials. All 3 companies, I mean, they have great salespeople that try to reach out and talk to you to convince you to go with them for one versus the other. And so in there, the approach enables the patient to think more carefully about what's most important for him or her. And I'm pretty happy with the decision I made. I mean, there's things I like about each of the other 2 companies, especially with respect to their connectivity. They're both a little better on the Bluetooth connectivity than this device. But that part changes. I know 5 years from now, I'm going to have Auracast and other kinds of great next generation Bluetooth capabilities that'll be really neat. And even though this company isn't quite there yet in terms of having as great a Bluetooth capabilities as the others, they're pretty good, and I like other characteristics of it. So in here, it represents some of the characteristics for factoring it in. One of a colleague of mine has done similar kinds of decision-making processes to assist expectant mothers that are making, again, a very complex, life-changing decision of what are called VBACs, vaginal birth after cesarean section. So after a C-section, a second-time mother who's had is making a decision: do they have a traditional birth or have a second C-section? Having a C-section where they essentially do surgery to remove the baby using it through a C-section, it is considered a riskier procedure to not do a C-section on a second birth. But there's trade-offs in there that are very complex, and they're what she did. She has a PhD in engineering management and did pairwise comparisons. She did an NIH, National Institute of Health sponsored research study to say, can we help these women make decisions about their birthing modality, their choice there, working with mothers with all different education levels and communication skills, making this very important decision. Doing a traditional vaginal birth is potentially considered a higher risk for the safety of the mother and the child, but but many people want to do it. Understanding the trade-offs so that they can make the best decision for their case was most important. So again, complex decision where the attributes, you're not making a decision of what's the lowest cost procedure or the highest profit, but you're making something that has all kinds of ramifications and trade-offs more profoundly, and that require thinking through what's most important to you and your particular circumstances. So this approach is used for picking companies, for public sector decisions, for projects, for example, for building a new bridge or building a highway system or a new office building, picking contractors where you need to make a systematic decision and be able to defend it if people want to challenge you, that you're not just picking your buddy and a company that might be giving you benefits. And so you want to make a justifiable, defendable decision. In fact, we have a whole class that goes through systematic decision-making, ETM 530, decision-making in engineering and management, that goes through these approaches in more detail. We're into bonus time. With that, let's leave it open for one last question, and we'll call it quits for tonight. Any more questions? Feel free to throw it into the chat. We're into bonus time. With that, we'll go ahead, wish everybody well and a good weekend. Thanks, and see you next week.